Right. See who just came in. All right, I'm going to just call out some names to see if you're here or not. Amna Arshad, you could just give a yell if I didn't get you. Dalton Cheney, Precious Farmer, Cecilia Iriola, okay. Ryan January here. Alfred Jones, Alexander Pascal, Matthew Scroy, Christopher Strawn, Megan Euro. Nobody hold out. All right, so I guess that's it for class today. All right, so what I'm going to do is I'm going to go to a PowerPoint. Today, we're going to review chapters 1 and 2 in your textbook. And even though the chapters 1 and 2 are lengthy in terms of reading, there's really not that much material in them. So that's why I'm covering it all in one day. And we'll start chapter 3 next week. And one other thing I wanted to mention to you that on next Wednesday, a week from today, it will not be class. I'll be pre-recording chapter 4, which is on sampling methods. So I'll send out an email reminder, and I will be pre-recording that Zoom session and posting it in Canvas. So again, no class next Wednesday. All right, but there will be class on Monday. All righty, so let me screen share here. I'll look at chapter 1 PowerPoint. This PowerPoint does come from the textbook, and I have posted this PowerPoint in Canvas for this week, both this chapter 1 and chapter 2's PowerPoint, so you can always go back and take a look. Let's do a second here. Okay, so yell out if you can't see it. I think should be on screen share, should be fine. So I don't hear anybody complaining, so I'll go ahead. All right, so chapter 1 is really, yes, go ahead.
Dalton got his major changed. He said he's not in this class anymore.
Who is it?
Dalton Cheney.
Dalton Cheney. So he actually dropped the course? Okay.
I think that's what he said, yeah.
All right, thank you for letting me know, and I'll make a note of that.
Okay.
Thank you. All right. All right, so chapter 1 is called The Benefits and Risks of Using Statistics. And it's really just an introduction of why we want to use statistics, because there's so much information that's out there right now, especially on social media, that it's sometimes very difficult to know what's true and what's not true, and what's based on facts and what's based on just hearsay. So this course is supposed to give you sort of a feeling for what, if you hear something, somebody claims something that seems to be numerical in nature, this book is supposed to give you an idea of what should you do? Should you just believe it without checking on anything, or should there be certain things that you check on to see if the claim is valid or isn't valid? So that's really what these first two chapters are all about, is just to give you that basic understanding. And I think most of it is common sense, I think. All right. So in this first chapter's PowerPoint, they're just giving you some, in the first couple slides, they're just giving you some hypothetical situations and asking a question regarding it. For example, in this one here, it says a recent newspaper article concluded that smoking marijuana at least 3 times a week resulted in lower grades for students in college. Okay. So the question, the first question is, how do you think the researchers came to this conclusion? Do you believe it? Is there a reasonable conclusion? Well, you can't really obviously answer these questions without digging a little deeper. Number one, they're making a causal connection here, right? They're saying smoking marijuana at least 3 times a week results in lower grades. Well, there might be a connection between these two, but there might be another variable that's responsible for this, not smoking marijuana, that results in lower grades. So these are the types of questions you should immediately come into your mind when you see a claim like this. Is, well, number one, how do they come up with this? And number two, can we really make a causal connection? In other words, is the smoking marijuana cause lower grades? Or is there just what we would call a correlation between the two things? So that's the type of thing that we'll be looking at in this course. Here's another one. On average, men have lower resting pulse rates than women do. So the question here is, how do you go about trying to prove or disprove that? Would it be sufficient to measure the pulse rates of one member of each sex? Anybody can yell out, does that sound reasonable, that you would just ask one person of each sex and then come to a conclusion?
No.
No, of course not. That's silly, right? So that's common sense. Obviously, there's variety of pulse rates for men. There's a variety of pulse rates for women. We would need a group of men and a group of women, right? Even 2 members of each sex wouldn't be enough. So, you know, this is why we have to look into it a little further, right? I mean, we have to, if we see a claim, we have to say, all right, well, how many men were chosen? How many women were chosen? And, you know, how did they choose these men and how did they choose these women to measure these resting pulse rates? That's sorts of questions that should be naturally coming to mind when you see claims like this. Here's another one. Suppose you were to learn that a large state university in a particular state graduated more students who eventually went on to become millionaires than any of the smaller liberal arts colleges in the state. Question is, would this be a fair comparison? Anybody?
No.
No, of course not, because it's a large university and you're looking at the number of students. Obviously, a larger university would have a larger number of students, right, who become millionaires. So how would you fix this? How would you, let's say you were comparing a large university has 20,000 students to a smaller college that may have 2,000 students. How would you decide? How would you come up with a better comparison? Anyone?
Choose a sample from the populations.
Sample, that's correct. And when you do your calculation, when you compare the two, instead of measuring the number of students, what would you compare?
The volume of students.
Volume, okay.
Percentage of students.
What is it? I'm sorry?
Percentage of students.
Percentage, yeah. Percentage, maybe when you said volume, I think maybe you meant the same thing like density or something. Percentage of students is the way to do it, because then you're eliminating the size of the college, right? The size of it, and percentage would be a better comparison. Okay, here's another one. Here's some, again, these slides obviously are pretty old, so this is from 1995. USA Weekend magazine asked readers, and I think that still exists, to return a survey with a variety of questions about sex and violence in television. Of 65,142 readers who responded, 97% were very or somewhat concerned about violence on TV. Based on the survey, can you conclude that at about 90% of all U.S. citizens are concerned about violence on TV? So the question is, could you do that in this case?
No,
And why not?
because the people that responded was through like voluntary, and the people that respond to voluntary studies are usually more concerned about the subject.
Exactly. Very good. And these were readers of USA Weekend magazine. They may all have similar viewpoints. People who don't read USA Weekend magazine may have different viewpoints. So you're absolutely right. In this case, it's very hard to take the results and generalize it to the whole population for two reasons. Number one, like you said, this could have been a voluntary survey, right? And number two, there might be a group of people that are not part of this USA Weekend magazine readership that are being left out. And therefore, this does not represent the whole population. It just represents a portion of the population. So for both reasons, you may not be able to generalize the 97% to the whole population. So very good. All right, so let's get to a definition of what statistics is. This is kind of a non-technical definition, because in this textbook, they're trying to make it as non-technical as possible. It's a collection of procedures and principles for gaining and analyzing information in order to help people make decisions. And this last little phrase here, when faced with uncertainty, that's very important, because that's the whole thing. If you have some uncertainty about the relationship among different variables and things like that, then you're never going to be absolutely sure, because you're not going to be able to ask everyone in a population. But there might be some procedure where you could take a smaller group of people from a sample, and then if you did the sampling correctly, you can be pretty confident that you can generalize that result to the bigger population. So that's what statistics is. And statistics is a pretty young science. It's pretty young. It's 100 years old in terms of what we do today, at the most. I mean, people have been using statistical methods for thousands of years, but not in a scientific way, not with using probability. So it's only in the last 100 years or so that it's actually been it's become a systematic thing that you can study and use. And I would say in the last 20 years or so, it's really grown. And you can answer many more questions than you did even 20 years ago. So, but it's a young science. It's very young. Now, the next couple slides basically are showing how statistics can be applied even in daily life. Even if you were going to decide which route to go to your school or to class or to work, you could try a few of them to see which one is best. And this is what we can call sampling routes. All right, we're using some sampling procedure. And that's what I'm going to talk about in the recorded video next week, is about sampling and how it's a scientific way of doing things now, as opposed to the way it was done before that. And then sometimes we use statistics to look at a claim that seems to be true, but we still have to check it out to make sure that there's some validity to it. I mean, here's an example here, which is very interesting. There was a psychologist named Lee Salk, and he was actually the brother of Jonas Salk. Jonas Salk is the one who came up with the first vaccine for polio. Jonas Salk was very famous back in the 1950s, and Lee Salk is his brother. I think the brother. Anyway, Lee Salk came up with this observation that in humans and also seems like in monkeys also, that there's a tendency for people to hold things that they find dear close to their heart, and notice the left side of the body instead of the right side of the body. So these are observations that have come up, and so this is something we could do an experiment on, or we can do an observational study on. But these are the types of things that we can check on. So anyway, these are again just observations. I think Lee Salk looked at rhesus monkeys at zoos, and they found that in 42 occasions, 40 out of 42 occasions, the mom rhesus monkey held the baby on the left by the heart as opposed to the right side when the mom was holding the baby. They also showed that out of 287 human mothers, 237 of them, or 83%, held babies on the left, regardless of whether they were left-handed or right-handed. Very interesting observation. Now, when you see observations like this, can you just draw a conclusion? Not yet. You have to go through some statistical procedure to see if there's strong evidence or not strong evidence. But the observations seem to indicate this is something that we could study, and we could even hypothesize about. It says here, out of 438 shoppers leaving store with one bag, exactly half carried the bag on the left. Well, I guess that's, this is exactly half. There's no preference in that case, I guess, because you don't have any emotional connection to your bag of groceries. But interestingly enough, it says dental patients asked to hold a 5-inch ball while their teeth were worked on. And it's interesting, substantially more than half held it on the left side when they were under stress. So when there's some emotional connection, then people tend to use the left side. It makes them feel better. So the people were holding the ball on the left as opposed to the right. So this is a conjecture. This is a hypothesis that Salk came up with. Maybe there was some survival value to doing this. Maybe something built into our genes. But having something that we feel emotionally connected to, we keep it close to our heart, and it comforts us. That was Lee Salk's hypothesis. Very interesting. But again, when you hear about this, can you just draw a conclusion to the whole population? Not necessarily, because what you really need to do is follow statistical procedures, and then you can possibly generalize it to the larger population. All right, so here's an example here where they did a controlled experiment. It was a nursery in New York City. So they had two groups. One group of newborns, they played over, I guess, newborns remain in the hospital for a little while. They played continuous sound of a human heartbeat over the loudspeaker. And the second group heard no sound at all. And then they measured the weight gain or loss after 4 days. And interestingly, the results came in that the infants treated to the heartbeat sound gained more weight and cried less. Interesting. So this was a controlled experiment to see if it was beneficial physically to the baby to hear the human heartbeat. So this wasn't the left or right side, but basically hearing the human heartbeat, and it actually calmed the baby down. All right, so this is what statistics is all about. You do some observations, you check things out, and you may come up with a hypothesis, and then you go through some procedure, either an experiment or an observational study, which we'll define in a little bit. And then we can maybe come to some conclusion. What does statistics do? It basically says, all right, we're going to detect some patterns and relationships, and then we're going to say, what if? What if it's true? All right? And that could, of course, lead to further questions also. So what are the types of questions that we can ask? Well, things that can be quantifiable, basically, things that we can measure. Like, for example, is the average man taller than the average woman? Does taking aspirin prevent heart attacks? All right. Is it more likely that someone will buy blue jeans in a certain month than other months? All right, you get the idea? It's just basically something that can be quantified. And if we have a hypothesis, we can try to test it. So when we do a statistical study, what do we do? Well, number one, we want a representative sample. Now, someone earlier had mentioned this idea about volunteers to a study. This happens in experiments, especially at colleges and universities quite often, is that they'll advertise for someone to take part in an experiment, and the person's really not randomly chosen. They're basically whoever answers the ad and they meet the qualifications, they're in the study. And what's the problem with that? Well, the sample of people that are in the study don't necessarily represent the population. So although the experiment may be well designed, you may be able to come up with some cause and effect conclusion, the results may not apply past that group of people that we're studying. So getting a representative sample is important, and that's something, again, I'll talk about more next week. We also want to make sure that the sample is large enough. All right, there are statistical procedures for calculating how large a sample should be. Now, in this course, we don't really go into that much in terms of how large a sample should be, the actual calculation. That's more for somebody who's taking the Stat 1 course, Stat 02260. That's when you learn how to do that, with your calculator. But that's not something that we do in this course. So we have to just assume when we read studies that the sample is large enough. All right, it should be stated. Number 3, you have to decide whether the study should be an observational study or a randomized experiment. So we have to make the distinction between those two types of studies. All right, and that will be, we will come up with a definition. I don't know if it's today, but certainly by next Monday, we'll come up with a definition of the difference between these two. All right, so that's basically the 3 things that we must do. Have the representative sample, make sure the sample is large enough, and determine what type of study we're going to be doing. Here's some definitions. Now, these definitions you need to know for this course. Whenever I'll be using these words throughout the course, sample and population. So what is a sample? It's actually the actual people who are studied. It's a subset, basically, of the whole population. And the population is the larger group from which the sample was chosen. Now, when people hear population, it doesn't mean that everybody in the United States. The population could be Rowan University students, or it could be people who live in where I live in Mount Laurel, New Jersey. It could be that particular city's population. So it has to be defined what the population is. And the sample, again, is just a subset of that. So what do researchers want to do? They want to take the results from the sample and they want to extend it to the whole population. I mean, what's the point of doing it, right? If you can't extend it to the whole population. And yet there's many types of samples and polls that are now done that are not scientifically done, systematically done. And in essence, you can't extend the results to the whole population. Why do people do it? Well, they're trying to get, they want to affect people's opinions, right? You see this particularly before an election, right? Because you hear these polls and all of that, and some of the polls are scientifically done and some of them are not. But sometimes the people who are doing the polling have some ulterior motive behind it, and they want to try to influence the way you feel about a topic. So that's why you have to be careful. Statistics can be misused, and sometimes intentionally. All right. Now, convenience sample. This is a definition of convenience sample. What is a convenience sample? It's basically what's easy to do. For example, if let's say in this class, I ask you to find a sample of people, sample of students, and ask them maybe some survey questions, okay? And let's say you decide, and you want this to generalize to the whole population of Rowan students. Well, if you just pick people in your class, let's say the pandemic ends and you're actually in class again and you're mingling among the students in the class. If you just select people in your class, that may not be representative of all Rowan students, okay? So this is called a convenience sample, right? And here they give the example of what if your class is just people on the track team, all right? So again, you might be looking at a specific group of people within the population and excluding other people if you do a convenience sample. How large the sample should be? What's large enough? Again, there are procedures. There's calculations that you can do to determine how large a sample should be. But in general, if whatever you're measuring doesn't have much in terms of variability, that means the numbers that you're collecting are pretty much close to each other, then you don't need as many people in the sample. If the numbers that you're looking at have more variability, that means the numbers are quite different from each other that you collect in the sample, then you need more of these measurements. So that's kind of a general rule, all right, without getting into the specifics of how to calculate it. So the more the variability of the data, the bigger the sample has to be. The smaller the variability, the smaller the sample can be. That's what they're talking about here with pulse rates. Observational study versus randomized experiment, all right? What's an observational study? And this is, again, non-technical, but it's merely observing things about our sample. Now, why would somebody do an observational study and not do an experiment? Well, maybe you're measuring something that you really can't experiment with. It might be harmful to people. For example, if you were going to see if the use of a hardcore narcotic had a bad effect on GPA or something like that. Well, you can't really do an experiment, right? You can't just randomly assign people to the hardcore narcotic and then other people would get something innocuous. It's unethical, and also you can harm people by doing that. So you have to do an observational study. You have to observe people. You have to collect data on people who do take narcotics and then check on how it's affecting their schoolwork, something like that. So we have to do an observational study in that case. All right. So experiments, the reason why you want to do an experiment is because you can control the conditions of the experiment, and therefore you can have a better chance to determine a cause and effect relationship between one variable and another, because you can, through what's called randomization, you can basically rule out other factors that could be causing the effect that you're looking at. So it's better to do a randomized experiment if you can, because you can do your look at cause and effect. However, as I said earlier, a problem with randomized experiments is that the people in the experiment are typically volunteers. So even if you can determine a cause and effect relationship in an experiment, many times you can't generalize it to the larger population, which is not great. Now, the observational study, the advantage of an observational study is that you can, typically you will do you will select people randomly to create a random sample. Again, I'll talk more about that next week. And so you can generalize the results to the larger population. What's the negative side of an observational study? Well, because you're not controlling the conditions of the study, you're not necessarily controlling for other factors that could influence the effect that you're studying. So cause and effect is hard to prove in an observational study. But on the other hand, you can easily generalize the results to the larger population. All right? So that's basically the difference between, in a very simple way, by the way. It's what we're talking about here is very, very elementary type consideration. It could get more complicated. There are types of studies out there that combine observational and experiments, and they're called hybrid studies, and you can get really complicated. But for this course, we're just looking at a very general comparison between these two types of studies. Now, is it worthwhile when you hear somebody or somebody in the media talk about a study to determine whether it's observational or not? Absolutely, right? Because if the way they're describing the study is that they're describing it in a way that there's a cause and effect relationship, and then you look into the, you go onto the internet and you look up the study and you realize it's an observational study, and you say, you know what? You can't do cause and effect in an observational study. The best that you can do is say there seems to be a connection between these two variables. You can't say that one causes the other. So it is worthwhile to know whether the study is observational or whether it's an experiment. It will change the way you perceive the study. So anyway, here's a case study here. It says, does aspirin prevent heart attacks? Well, this is cause and effect, isn't it? I mean, the way the question is asked. Does aspirin prevent heart attacks? All right, so what is the effect? The number of heart attacks, or the frequency of heart attacks. And what is the cause? Taking aspirin. All right, so unless this is an experiment, you can't say taking aspirin prevents heart attacks. So what did the study do? It says it's a 5-year randomized experiment. All right, that's good. That's number one. It's randomized experiment. We can talk about cause and effect. But look who the subjects are. There's 22,000 people in the study, but they're all male physicians. They're all male doctors. And they're all between the ages of 40 and 84, so there's no younger doctors in here. So group 1 took ordinary aspirin tablet every day, and then group 2 took what's called a placebo. It's defined a little bit later. And so this is something that has no active ingredients that they took. Subjects didn't know which group they were in. But even if this experiment was well designed, you couldn't generalize it to the whole population. You could only generalize it to the population of what? Anybody? Hopefully I didn't put you to sleep.
Middle-aged male men?
Yeah, middle-aged male, and not just men, physicians, doctors. That's the group. That's our population. Middle-aged male doctors. Okay? Well, there's lots of other people who are in other professions, right? And that are male too. I mean, they're not just, so you can't even generalize it to all males. You can only generalize it to all male doctors. So is that a bad thing? It's not a bad thing, this study, but it does, if the intention of the researcher was just to look at male doctors who are ages 40 to 84, great. But if that was not the intention, you can't generalize this to everybody. Okay. All right. in this case study here, and here's the results right here, right? Here's the results. Now, the results, now some of the ways that we will be presenting data will look like this in a chart form here. And this is sort of what's called a contingency table. We can also call it a frequency table. Basically, we have different categories here. We have the type, whether a person had a heart attack or no heart attack, and then the treatment. Did they get an aspirin or did they get this fake aspirin called a placebo? And then we count the number of people in these groups, right? There's 4 groups. There's people who took aspirin and had a heart attack. There's people who took aspirin and had no heart attack, like that. So what can we do to make a fair comparison? All right, because look at the heart attack group, much smaller than the no heart attack group, right? Much fewer people in the whole study that actually had heart attacks than people who didn't have heart attacks. So what do? Well, you determine the number of heart attacks per 1,000 people, per 1,000, right? Number of heart attacks per 1,000. So it's 104. You figure out how many total people who were in the study, and then you determine who actually took aspirin. How many people took aspirin? It's 104 plus the 10,933. And so that total, you divide 104 by the total, and you get 9.42 per 1,000 people. It did the same thing with the placebo. And notice that this calculation here, you can see pretty quickly that there was a big difference between the two, right? They even said, actually, if you look at the heart attack per 1,000 with aspirins and the heart attack per 1,000 for people who took placebo, this number is 50. This number 9.42 is 55% of 17.13. So it's a little more than half of the heart attack rate for people taking aspirin versus placebo. Is that worthwhile knowing? Absolutely. Now the question is are these two numbers so different that we would say, does aspirin prevent heart attacks? We would say, yeah, it seems very likely. The question is there some procedure for that? And the answer is yes. But that's not something we're going to necessarily study in this course. What we're going to do is take a look at a chart like this and come to some conclusion like this. Heart attack rate in aspirin group, only 55% of the rate in the placebo group. All right?
I have a question.
Yes, go ahead.
So I was looking, so it says 5 years, but how did they choose to do 5 years? Because I know timing's important, but why 5?
Good question. Over 5 years, because I think heart attacks are not that frequent. It's not like people get heart attacks all the time. As you can see, that over a 5-year period, there were only 104 for the aspirin group and 189. So I think they wanted to have a large enough time period where they would have sufficient data. So that's a very good question. Why did they pick 5 years instead of 1 year or 6 months? It's just because if they picked a shorter time period, this is just my guess, that they wouldn't have enough data to even run the study. Does that answer your question?
Yes, thank you.
But it's a very good question, because it seems, kind of strange, right, to see an experiment that lasts for 5 years. But look, sometimes we do run them, or scientists do run them that long. All right, now, here's another term here for an experimentation. It's called randomization. What's randomization? Basically, what we want to do is assign people to different treatments or assign treatments to different groups of people randomly, so that in general, the groups that we set up, that's the aspirin group in this case versus the placebo group, are similar for other characteristics such as age and gender and maybe occupation or diet, whatever other factors they're looking at. So this process of randomization, that means they randomly assign, and you can picture, in a crude way, you can picture this, right? Where you just put people's names into a hat and then just say, all right, I'm going to pick somebody out. I'm going to pick maybe the first 300 people out, and that's my aspirin group. And then you're going to pick, the rest of them out and say, that's my placebo group, like that, in a random fashion. They don't use hats and put names on papers, but they'll use some computer software to do that. All right, and the whole idea is to nullify other factors that could be there that could influence the results. So you want to sort of like make them, they basically net out those those other factors, so that what you're left with is aspirin versus placebo and the number of heart attacks. All right, and you can do that when you do an experiment, this randomization process, and you have treatment groups. When you have a observational study, there's no treatment groups. Basically, you're looking at just results. You're just looking at, people. If this was an observational study, you would basically ask people, have you had any heart attacks in the last 5 years? And maybe how do you take aspirin? That sort of thing. And what's your dosage and how often do you take aspirin? Those types of questions. And then you're not ruling out other factors that could influence whether you have a heart attack or not, because it may not be aspirin, right? It could be your diet, could be exercise, could be your age. So observational studies, if you don't design them correctly, or not even design them correctly, in most cases, you can't rule out other factors. You could try, but it's going to be hard. In an experiment, through randomization, you can rule out other factors. All right. And then this last statement here is what I mentioned last time, subject for male physicians. All right. And then I do need to go to the next chapter. Again, I'm just showing you examples here. This particular section here deals with possible ways that people misuse statistics, trying to deceive you and all of that sort of thing. Here's a business magazine sending out 2,000 questionnaires to their readers, right? This is back in the year 2000 when, and again, this was 20 years ago. So many of you were little ones, maybe not even born yet. But anyway, there was a Republican primary. You know that George W. Bush was president, became president in 2000, but he did have some opposition in the Republican primary, and one person who opposed him was the president of Chrysler Corporation, the car company. His name was Lee Iacocca. And so anyway, this business magazine did this survey and asked the first 200 respondents, who do you prefer? And 54% of them preferred Lee Iacocca. They thought he would beat George W. Bush. Well, George W. Bush won big, and Lee Iacocca didn't get much of a response at all. He lost pretty quickly. And the reason that you got this result here is because, number one, this was a business magazine, right? And Lee Iacocca was a businessman. George W. Bush was, of course, George H.W. Bush's son. And he did not have a reputation of being a good business person. So most people who were business people didn't really think much of George W. Bush. So it's not surprising that a non-random sample, right, a convenience sample, you can say, of respondents of this business magazine would pick Lee Iacocca, who was a successful business person. But this sample did not represent the population in any way, because it only represented business people typically, who were just looking at the business credentials of the people running. And many people liked George W. Bush, and at least the Republicans, and they favored him highly over Lee Iacocca. So this particular study here, this observational study, this poll, was not representative of the population. Okay, and you get very distorted results like this when it's not representative. There's a famous study from, and I won't go into much detail now, but there's a famous study like this from 1936. This goes back a ways. This is before, way before I was born. And Franklin Delano Roosevelt was seeking his second term, and he was running against a fellow named Tom, I forget his name. I think it was the mayor of New York, but I don't remember his name off the top of my head. But it doesn't matter. It was something similar to this. It was a magazine that was for people who were wealthy individuals. And, you know, the Republican was heavily favored by these people. They were Republicans. So in the same way that this was done, there was a couple million people that it was a very famous magazine, and a couple million people subscribed to it. And it showed heavily that Franklin Delano Roosevelt was going to lose in a landslide. Well, the results ended up being in reverse. Franklin Roosevelt won in the landslide, and that's because the people who subscribed to this magazine were a small portion of the population, wealthier people, Republicans, and it didn't represent poor people. There were, you know, it was during the Great Depression, and they left out a huge segment of the population. So if the sample doesn't represent the population very well, then you can get very distorted results like this, like you're seeing here. All right. Also, the way statistics is presented can be misleading. Here's something that was done with New Jersey. This is back, I don't know, many years ago, I guess. It was EPA study. EPA is the, has to do with the environment. And back in this particular year, they said that New Jersey ranked 22nd out of all states in its release of toxic chemicals. Well, how were they measuring it? They were measuring the total pounds released. And New Jersey, as you know, is a small state, right? Compared to New York, California, Texas, Florida, small. So what did they do? Well, they, you know, I mean, what researchers did was they said, wait a minute, this is not right. Let's look at the number of pounds of toxic chemicals released per square mile, right? So you're correcting for the size of the state. And now New Jersey ranked 4th on the list of toxic chemicals. Now, as you know, South Jersey doesn't have toxic chemicals, but if you ever drove up to North Jersey, you can smell the toxic chemicals as you're driving on the New Jersey Turnpike as you go towards New York. So I am sure this was based on North Jersey, not South Jersey. All right, but I'm biased. I live in South Jersey, and you are too. All right, anyway, so it was better in this case to present statistics that were adjusted for the size of the population. So again, did the study make a mistake in releasing total pounds released? I don't know. Maybe they intentionally did that so that New Jersey looked better. Who knows? That's why you have to be careful when you look at studies. All right? All right, anyway, I want to go, I only have a couple minutes left. I want to look at the next section and just give you an idea, the next chapter. The next chapter, there you go, deals with reading the news. So there's not a whole lot here in this chapter. That's why I'm not spending so much time on it. I want you to read through it just for your own enjoyment. But I want to bring out the critical part of what they're talking about here in this chapter, so that gives you sort of an idea of the types of things that you would look for when you hear the results of a study. Let me just go directly there. And then also, before I do that, there is a definition in this chapter that you should know. But again, these are very basic definitions. The definition of data, all right? Data is actually a plural word, all right? So when the people talk, they say data are instead of data is. And it's referring to a collection of numbers or other pieces of information. It doesn't have to be numbers, to which meaning has been attached. All right, so much of data is numbers. And when somebody takes information, data, and wants to put it into a computer software program, they typically convert everything to numbers. All right. So this is what's called data. All right. So far, our definitions are pretty simple, I hope. I think we learned about the definition of statistics, definition of data here, observational study versus an experiment. That's basically what we've learned so far. And these first few chapters in this book are all definitions and concepts. So I will be telling you as through all these recordings exactly what you need to know. So those are the definitions you need to know so far. It's just basically a collection of numbers for something, and it says pieces of information to which meaning has been attached. So sometimes we call these variables. All right. So it could be the heart rate of somebody running. It could be the height of somebody. It could be how you answer a question in a survey. All of that is considered data. All right. So the point they're making here in the second part here is they're saying the numbers themselves are not necessarily data, but when you put units onto it, then it becomes data. All right. So the numbers 1, 3, and 10 don't mean anything unless there's some units attached to it. So I hope that makes sense. All right. Now, what they're in this chapter, what they're trying to tell you is when they say newspapers, you can also say, the social media too now, right? Because most people don't read newspapers anymore. I still get them because I grew up with newspapers, but your generation certainly probably doesn't read a newspaper. You probably go onto Facebook or other media sites to get your information. So so we can change this here and say newspapers / social media rarely present actual data. And to be honest with you, you guys are actually presented with much more data, and basically data that may be even hard to verify. Newspapers, at least in the past, would have reporters, and they would do their best to make the reporting as honest as possible. But the data that you guys are presented with every day may not be even close to that. Meaning attached to data and the results depend on how well the information was obtained and summarized. That's always been true. Many times, if it is a reporter, as if the reporter is reporting on a specialty like medicine or something, the reporter may have a background in that. So, and they may have a way of presenting it and summarizing it. So yes, so that is true. That it depends on how you determine the meaning of what you're looking at. Does depend on how well the person put together the information and summarized it for you. What are the various origins of news stories? We mentioned here academic conferences, published articles in scholarly journals such as the Journal of Medicine, government and private agency research reports. There are, and maybe I'll show, maybe sometime during the semester, we'll actually show you some examples of actual data sites that you can go to, and that's public sites, and you can actually download data yourself and analyze it. University media offices, I guess, but news stories now come on social media, so there's more now available, Facebook and so forth. So, all right. So this is the critical part of this chapter here. The components. There's 7 components that you should, if you were going to do a thorough job in researching a study that you were looking at, these are the 7 components that you would look at. All right. So I don't know if anybody actually does this, but this is what is recommended by this textbook. Component number 1 is the source of the research and of the funding. Now that's important, right? I mean, who's doing the research, right? And who's funding it, right? So if you hear some, study or something, that's political, let's say, Is it being funded by an organization that has political leanings, right? Democrat, Republican, or some other group, Russian? Component number two, the researchers who had contact with the participants. In other words, if this was, for example, an experiment, who were the people who were actually conducting the experiment? And did they have themselves any biases in the way they presented the study? Component three, the individuals or objects studied and how they were selected. That's very important, right? Is this observational? Is it an experiment? Were they volunteers or were they randomly selected? That's component number three. Component four is the exact nature of the measurements made or the questions asked. Okay, so if it was something, a physical measurement like height, that's pretty straightforward, right? Somebody's height or somebody's weight. But how about survey questions? How did the research come up with the phrasing of those questions? It's been shown actually that how you phrase a question could influence your response to that question. How you phrase it. Just sometimes switching one word out from a question can have a huge effect on the results of that question. So there's a whole science behind questionnaires in the use in surveys, and but that's component number four, all those issues I just mentioned. Question five, or component five, is the setting in which the measurements were taken. In other words, is it a controlled setting, unnatural setting like an experiment, or is it a natural setting, such as an observational study? Component six, differences in the groups being compared in addition to the factor of interest. In other words, can you break the data up into different groups? All right, you can break it up in terms of age groups maybe, or in terms of gender, that sort of thing. You get different results. And then component number seven, which is never really talked about much when results are mentioned, but are definitely talked about or calculated when you actually do research. And that's called the size of the claimed effects, the size of it. Is it a significant result, or is it a small result? If we're looking at two different groups, is the difference significant or not? That's basically important too. In statistics, just in general, there's procedures we go to determine if there's whether an effect is significant or not. We call it statistical significance, but it has to do more with the statistical properties of the study. It doesn't really say anything about how large these effects are. And you can have a statistical, let's say you're looking at two groups and you're measuring, let's say, the difference in heights between basketball players and gymnasts, all right? We know the basketball players are much taller than gymnasts. So the question is, between these two groups, are we going to see a statistical significant or a statistically significant difference between the two groups? Well, that's determined by the procedures that we use in statistics. But is the size of the effect large? Well, I would think so, right? It would be definitely gymnasts are typically much smaller in height than basketball players. So we would expect there to be a significant difference. So component 7 is something that's important, the extent or size of the claimed effects. Again, not mentioned much in what's reported in the press. All right, so what I'm going to do in the next few minutes before we take attendance in the end, or at least I take attendance in the end, and then we'll move on, is I want to go over an example of these components. And let me see if I can find one that, I think actually let's look at this one, because I think they're looking at examples of each component. So component one, the source of the research and of the funding. So three main reasons that studies are conducted. Now, a study could be conducted by a government agency, federal, state, or local, or private companies. Private companies do studies all the time. They want to see, for example, if they have a new product, they want to see if the product is something that appeals to the consumers. All right, so they're very much interested in doing studies. Number two, universities do studies, right? Or institutes do studies, scholarly institutes. And why do they do it? Because, well, maybe that's part of what their faculty do. You know, they get published and all of that. Sometimes other groups are paying the universities in these institutes to do these studies. So that's something you have to look into. Number three, companies to convince consumers their program or product is better. Many times they're not really interested to see if their program or product is really better. They're trying to convince them it's better. So these are the types of studies you have to watch out for. The ones where they're trying to manipulate you, right? Manipulate your decision making. All right. Little caveats at the bottom here. Not always easy to discover who funded research, right? Sometimes it's hidden. Sometimes they don't tell you. Would funding organization have a strong preference for a particular outcome, right? It's possible, right? A political group you can picture. So yes, these are important issues for component number one. That's why you would need to know the source of the research, who's doing that research, and also who's backing the research. Is it that organization, or is it somebody else backing it who's providing the funding? Because it could be that they're trying to influence the outcome. Component number two, researchers who have contact with the participant. Many times we need to know who they are to see if, for example, if the researcher is somebody who is sitting with people and interviewing them and asking them questions, the question that you have to ask is, are they influencing the response of the people being interviewed? Is there, I mean, an obvious example down here would be having a uniformed police officer survey about illegal drug use. Now, who in their right mind who's taking illegal drugs would tell an officer, oh yes, I take illegal drugs, and I take them very frequently? I mean, you wouldn't expect an honest response. So knowing who the researchers are and determining, if you can, whether they are influencing the respondent, especially in survey type questions, is very important. All right, so that's important to know. And component number three, the individuals or objects studied and how they were selected. So who are the people who are being studied, or what are being studied, right? It doesn't have to be people, it could be objects, right? It could be, you could be measuring the number, you could be counting the number of fish in a pond or something like that. It doesn't have to be people. You have to know how the participants were enlisted for the study. So was there a randomly selected, or were they raw volunteers? It mentions here that voluntary responses to surveys are often biased, as only those who feel strongly are likely to respond. All right. So we know that there could be a bias there in the sample results. Therefore, we can't really generalize results to the whole population. So knowing about how the, not only knowing about who the individuals are or objects studied and how they were selected, what sample procedure was used, is component number three. Component four is basically once you have the sample, how do you measure what you're measuring? What questions are asked if it's a survey, right? Is something that we're measuring difficult to measure? An example would be something that is not directly measurable in a survey. For example, Um, let's see, let me think of one. Um, you might want to know whether a person is a believer in individual freedom or likes the idea that a person should, um, if necessary, give up their individual freedom for the benefit of the group. Well, how do you measure that? Well, you might have to ask a series of survey questions. And then there's certain statistical procedures that are used to determine if those questions actually measure that. So sometimes what we're trying to measure may not be easily measured, like measuring somebody's height or weight. So we need to know exactly what they were trying to measure and how they were measuring it. Do you need some statistical background for that? Unfortunately, for component number 4, you may need that to understand how this could apply to the study that you're using. But in many cases, you still can take a look at, oh, somebody is coming in. Precious, all right. A little late. Welcome, Precious. The wording or ordering of questions could influence the answers also. All right, I mentioned that to you before. How we word a survey question, and believe it or not, how we order the information in a survey question can also influence responses. Again, I took a course, an entire semester course in graduate school on this topic of wording and ordering questions and things like that. Basically, what affects survey questions. So it's a very complicated topic. All right. And I'm just going to finish up the 7 components, and then we'll call it a day, and then I'll take attendance, okay? But do read through the 2nd chapter because it gives you many examples of how to apply these components. So just read through it, and shouldn't be any issues in terms of applying these components. Now, component number 5 is the setting in which the measurements were taken. In other words, where was the measurements taken, and how were the measurements taken, and when were they taken? You could picture, for example, just as a silly example, but you could picture that if you were taking a survey at 10 o'clock at night versus 10 o'clock in the morning, you might give different responses because of how tired you are. All right, so certainly that would be an example where the setting in terms of time of day could affect the survey responses. Now, you may not have that type of information when you dig deep into a study, but it's good to know this anyway if you can. Also, they mentioned here, telephone calls in early evening would exclude those who work evenings or often eat out. So anyway, also the last point here, research in a lab at a university may not extend to a natural setting. So this is where settings are important. And then again, 2 more components, and then we're almost done. Differences in the groups being compared, in addition to the factor of interest. So we want to see how, if we're going to group people into different categories, like age groups, for example, and we want to compare them. We want to see in what other ways do the groups, or in what other ways are groups different, possibly different, and do the researchers take that into account when they did the research? Now, this is a little technical. Do you need statistical background for this? Probably yes, but at least you know that this is something that's important. And then component 7 is the size of the effect. It says here, the media may state a treatment had an effect, but often don't tell you the size of it. And the question is the size big enough to actually have a practical significance? So with the aspirin and heart attack example, the media reported taking aspirin every other day reduced the risk of heart attacks. Is it worthwhile taking aspirin? Well, it's better to say that the rate was reduced from 17 attacks per 1,000 without aspirin to 9.4 attacks per 1,000 with aspirin. Is that significant? That seems significant. I would say that's probably a case where you would say, yes, the size of the effect, it did change quite a bit between the 2 groups. So this is, again, if it wasn't reported that way, then you can recalculate things in terms of the number of heart attacks per 1,000, and then you could see that there is a significant treatment effect in this case. All right, so anyway, that is it for these 2 chapters. I hope I didn't put you to sleep. I'll take a quick look. No, nobody. Oh, there's one person looks asleep. All right, sorry that I woke you up. But anyway, let me just take a quick look at the number of people. 24 people. Let me see if there were 24 people. I think Precious came in a little bit late, but you were here. So let me see. And I think that's about right. All right. So anyway, so what are we going to do for next week? We're going to look at chapter number 3. And chapter number 3, let me just get the textbook out here. Chapter number 3 is on measurements, I think. Just take a quick look. Measurements, mistakes, and misunderstandings. And this is a chapter where we're going to go into a little more detail for some definitions. There wasn't much today. And again, read through the first 2 chapters if you haven't already. So we're going to look at the different ways of measuring things in chapter number 3. And again, we'll have some definitions in here that you need to know. So I will point those out to you. And remember, the very first quiz will be on September 21st, Monday the 21st. So we'll have that available to you in Canvas. So make sure that when you come to class on the days that we have a quiz or a test, make sure, well, come virtually to a class, make sure you have access to Canvas that day, because you will be taking the quiz and test during our meeting, all right? And it'll be in Canvas, all right? And then remember, next Wednesday, there's no class, but I will be pre-recording chapter 4, which is on sampling. So that's actually a good chapter to actually do a pre-recorded class on. All right, so that's it for today. Any questions or comments? Okay, all right. And I will try to make this a little more interesting. I know that this probably put you to sleep a little bit, but don't worry. I will have things for you to do during future classes. So that's it for today. I'm going to turn off the recording now, if you don't have any questions. And this will